we are starting our last unit, our last section of unit 1. So the last section of unit 1 is called 1.3 Intro to Piecewise Defined Functions. Okay. So as far as it goes, we're going to watch a little introduction video. It's about 4 minutes long, and it's from Khan Academy. And he's just going to explain to you what a piecewise function is the introduction. And I want you to do nothing but watch. So you're not working on the activity, you're not listening to music, you're not doing anything else, but just watching and trying to absorb what he's saying about a piecewise function. Okay. So Josh, Justice, got to pause a little bit on the action. And then, because if you don't watch this and then you're going to ask me questions, kind of defeat the purpose. But so we're gonna.
By now, we're used to seeing functions defined like h of y is equal to y squared, or f of x is equal to the square root of x. But what we're now going to explore is functions that are defined piece by piece over different intervals. And functions like this are, you'll sometimes view them as a piecewise, or these types of function definitions, they might be called a piecewise function definition. And so let's take a look at this graph right over here. This graph, you can see that the function is constant over this interval for x, and then it jumps up to in this interval for x, and then it jumps back down for this interval for x. So let's think about how we would write this using our function notation. So if we say that this right over here is the x-axis, and if this is the y is equal to f of x axis, then let's see, our function f of x is going to be equal to, let's see, there's 3 different intervals. So let me give myself some space for the 3 different intervals. Now this first interval is from not including -9. I have this open circle here, not a closed-in circle. So not including -9, but x being greater than -9 and all the way up to and including -5. So I could write that as -9 is less than x, less than or equal to -5. That's this interval. And what is the value of the function over this interval? Well, we see the value of the function is -9. It's a constant -9 over that interval. It's a little confusing because the value of the function is actually also the value of the lower bound on this interval right over here. And it's very important to look at that this says -9 is less than x, not less than or equal. If it was less than or equal, then the function would have been defined at x equals -9, but it's not. We have an open circle right over there. But now let's look at the next interval. The next interval is from x is greater, or -5 is less than x, which is less than or equal to -1. And over that interval, the function is equal to, the function is a constant 6. It jumps up here. Sometimes people call this a step function. It steps up. It looks like stairs to some degree. Now it's very important here that at x equals -5, for it to be defined only one place. Here it's defined by this part. It's only defined over here. And so that's why it's important that this isn't a -5 is less than or equal to, because then if you put -5 into the function, this thing would be filled in, and then the function would be defined to both places, and that's not cool for a function. It wouldn't be a function anymore. So it's very important that that when you input -5 in here, you know which of these intervals you are in. You can't be in two of these intervals. If you are in 2 of these intervals, the interval should give you the same value so that the function maps from one input to the same output. Now let's keep going. We have this last interval where we're going from -1, we're going from -1 to 9, from -1 to +9, and x, it starts off with -1 less than x, because you have an open circle right over here, and that's good because x equals -1 is defined up here, all the way to x is less than or equal to 9. And over that interval, what is the value of our function? Well, you see the value of our function is a constant -7. A constant -7. And we're done. We have just constructed a piece-by-piece definition of this function. And actually, when you see this type of function notation, it becomes a lot clearer why function notation is useful even. And hopefully, well anyway, hopefully you enjoyed that. I always find these piecewise functions a lot of fun.
I guess the new school will have glass walls, and I was just taking a look out. Glass walls? Yeah. What? Yeah, that's weird. This wall. Oh. They said that curtains should be installed if you need to like close off, but yeah, I mean, giant walls. How would that say?
That is not.
So the plan for that is that there's gonna be like. This is not me. Oh, I'm being recorded. So, like you talked about in here, we're going to be doing what's called piecewise defined functions. Piecewise defined functions are how most of our functions in this day and age are really defined, like real world situations. When you did your performance task, you noticed how was it a constant change or a constant decrease or constant increase? No, it fluctuated depending on the interval of time you looked at, right? That's the real world. We can't say when a store opens, starting at 6 o'clock every hour, we're gonna have 63 people coming to the store, right? Maybe. We can't just say that that's gonna happen every single time, right? And then when it gets to closing up, we're gonna leave at a rate of 25 people every hour, okay? It's not gonna be that easy because that's what so many factors are unpredictable. That's where we use piecewise functions. So piecewise functions help us kind of make sense of that, all right? On the back of your handout that you got, we're going to take notes. So on the back, it should say 1.3 a blah, blah, blah notes, right? That's where we're going to take notes at. On the back of it, I would like for you to write down the problem that's on the board. While you're writing down the problem, I'm going to come around with a little graph sticky note that's going to go on the bottom left of your notes, okay? Got it? Yes, you're writing down the piecewise function. So we have f of x equals 2 minus x, and you don't have to write if, you can actually write comma, because that's what the comma means. Yes, you do. Okay. Janae's been a responsible student. She's not here. She's logged into the room. All right, so you're writing it down, and I'm going to come it around with your little graph. Again, you're going to put it in the bottom left of your note, or right, just in the bottom somewhere. Okay. I'm going to get my symbol now. On the back. How do I get everyone to graph? You should be good. Huh? It's just the nice way. It's for the next problem, not problem. All right, so how many of you did your do now? Oh, let's get this over. Wow, they're doing a video for. I gotta do online for. All right, so your do now has you evaluating, right? Evaluating means that you're given the values of the variable and you're substituting them in, correct? Yes. Okay, so here we have. It wants us to evaluate at x equals -3, -2, 1, and 2. Okay, because we have specific intervals, that means that we have certain numbers that use different pieces of this function. So we have 3 pieces: piece 1, piece 2, and piece 3. If a number is between -3 and -2, but including -3, we use the first piece. If a number is between -2 and 1, and including -2 and 1, we're going to use the second piece. If the number is between 1 and 3, then we're going to use the third piece of the graph to evaluate. In terms of interval notation, this is saying we're going from -3 to -2, not including -3. We're going from -2 to 1, and we're going from 1 to 3. Okay, just like when you're doing your average rate of change, this is your starting and your stopping. Does that make sense? Your interval represents where you start and where you stop. Okay, so for f of -3, which one of these intervals does -3 fall on? On piece 1, piece 2, or piece 3? The first one. So we're going to use piece 1 to evaluate. So this is where we're going to plug in -3 for x. So we have 2 minus -3. A negative times a negative makes a positive.
Oh.
I wrote the answer, not the thingy. So therefore this equals 5. Do we all get why we chose piece 1? Okay, I see a head no. We chose piece 1 because looking here, this says that if x is equal to or greater than -3, you use this. This expression if this is true. This expression if this is true, okay? So because this -3, it falls on this interval. So I'm going to use the first expression. Okay, so in the, okay, all right. How can I rephrase this? This is where any number, this is a number line. Like if I have a number line that starts at -3 and ends at -2, I can use any number on this number line, going back to middle school. Whatever, as long as the number is -3 or any number in between, I use expression 1. Is -3 on this number line. So therefore I'm using expression 1. The numbers on this number line are from -2 to 1. Does -3 fall on this number line? No, so I can't use expression 2. This number line, the numbers are from 1 to 3. Do y'all remember doing this in elementary school with the number lines in the open and closed circle? Okay. This should have been like 4th, 5th grade and a little bit of 6th grade. Yeah. Okay. All right. So the numbers here are in between, right? And the open circle means that it's not included in that option. The closed circle means that it is included in that option. Okay. So -3 is on which number line? The first one. So that's why I use the first expression. Okay. All right. Now it says evaluate -2. So f of -2. Which interval does -2 fall on? The second one. So I'm going to substitute in for x -2. So we have 1 minus -2 squared. What is -2 squared? 4, positive 4, because a negative times a negative is a positive. And what's 1 minus 4? -3. So f of -2 for this piecewise defined function is -3. Okay. All right. Now it says evaluate 1. F of 1. What interval does 1 fall on? The second one, because at the second one, it's a closed circle, but on the third one, it's a what? Open circle. It's not included in that interval. It's the starting of it, but it's not included. Does that make sense? So I can have 0.99, like 1.11111, but not 1. Does that make sense?
It's only included when the exponent has the
Equal to. Okay, so we're using our second interval, our second expression. So we're plugging in -1 for x. So we have 1 minus -1 squared. That's going to give us 1 minus 1 equals 0. Okay. Our last one, f of 2. What interval? Oh, my negative didn't make it. There you go. It's going to be the third one because I didn't mean to write -1. 1 minus 1. Oh, I don't know why I wrote -1. Just making sure, just make sure you were paying attention. That's all, trying to catch you off your game. It's on the back. You're writing it down yourself.
What is it too? So
F of 2. So what interval did we say for 2? The third one. For the third one. So we're going to plug in 3 x, where x, plug in 2 for x. That gives us 2 to the third, which equals 8, right? Good job. 2 times 2 times 2 is 8. How do we feel? Okay, because is 2 between 1 and 3 on this number line? Yes. Okay,
Number that's in the principal function of those is substitute for x, right?
yes.
Where do we get the -1 from it? That's 1.
These are our intervals. This is where it says you're starting and stopping. You use this function. You start, stop using this function. You start, stop using this function. So those are your windows, are telling you what number goes in where. We just did the third one. Yeah, we did 2. 2 falls in between 1 and 3.
I don't think you wrote, oh, it's just 1 minus 1 squared.
1 minus 1 squared. It's a positive 1.
It's -1 squared.
It's positive.
Which is 1, and 1 minus 1 is 0. Like, I got the same answer. Like, you're right away.
Because I actually made a negative and I just turned into a positive, so I wouldn't have to re-erase.
It's going with the,
I just wanted to make sense as to what I was plugging in.
it's going with -1 comes from the front.
Where is -1?
And f of 1 minus 1 squared, I don't see where 1 minus comes from.
It's from the expression, right here, it says 1 minus x squared. And we substituted in for x. Okay.
What, so it's from.
Gotcha.
That makes sense.
All right, checking your knowledge. Ready? Here's yours. Take a moment, think about it quietly. F of 0. Don't say it out loud. I'm gonna give you 30 seconds to just check. What is f of 0?
Did it go through?
Are we ready to check? Oh, okay. Okay, all right, what interval did you use? 1, 2, or 3? And why did you use 2? Hey, perfect. 0 falls between -2 and 1. So you should have used 2. And so you're substituting in 0 for x. So we have 1 minus 0 squared, which is just 1. Yeah? We're taking notes on the back. Okay, how we feel? Do we need to do another one? Okay. Yes. All right, so we'll do another one really quick. All right, f of -1. Evaluate at f of -1. Ready? What interval did you use for f of -1? Why are you using 2? It's in between. It's on this number line somewhere, right? So you're going to use 1 minus -1 squared, and it's going to give us what? It was a 0. A negative has a negative is a positive. So we get 1 minus 1 is 0. That is it. That's all you're doing. You are given the value, you determine the interval, you plug it into that expression. Okay, yes. All right. Questions, comments, concerns about evaluating? No? We're good? Okay, because the next part is graphing, which is why I brought you the little graph paper. So if you have the graph paper, it's going on the bottom corner of your notes, and we're going to be using that. So that's where you just add it there. All right, are we good? Okay, if you just came in, you're going to have to watch the video or get the notes from Canvas because I have to keep going. All right. All right, so the next thing you're gonna write down, f of x equals 0.5x squared, and you don't have to write the word if, you can always put a comma. The comma means if in a piecewise. Yes, so you're writing down, write me.
Did you, is that the only other one we're gonna look it up?
That's all we're gonna do in the there. Write me. Okay, you're gonna write down 0.5x squared if x is between -4 and -2. You're gonna write down x if x is between -2 and 2. You're gonna write down x squared minus 4 if x is between 2 and 4. We're gonna sketch your graph. We're gonna determine if it's continuous, and we're gonna solve for f of x. No, it's not. Stay positive. All you're doing is writing right now. You're gonna see it's not that terrible. Ready? Okay, so we're gonna start with the first one. So we're gonna start here with number 1. Okay, number 1, it says for numbers between -4 and -2. Okay, I'm gonna draw my boundary lines. They're just dashed lines at -4. On your graph. I gave you a graph. Yeah. I thought you would see that I put the picture up here for you. Sorry, I thought we would catch on
Okay, so yeah.
without me saying draw an axis. My bad for assuming. You're right. It doesn't matter. Just go down the center vertically and horizontally. Okay, so I have -4, -2. Those are my boundaries. Agreed? Yes. Okay, I'm going to find the values of my boundary. So therefore, I'm going to find f of -4, and I'm going to find f of -2. Are you with me? I didn't know it was going to take you a while to draw lines. My bad. What are you counting? Oh my gosh. F of -4. Okay. So what is that? What's -4 squared?
Oh, that's
16. And what's half of 16? 8. So at -4, I'm going to go to 8, and it's going to be a closed circle. Why is it a closed circle? Because it's equal to. Remember, if it's less than or equal to, it's a closed circle. If it's strictly less than, then it's an open circle. Do you remember those rules? No one's like, she's making this up. All right. Okay, now we're going to do -2.
Wait, how do you get 8? How do you get?
We substitute in -4. -4 squared is 16. 16 and half of 16 is what? 8.
Oh, wait, so what do you get this? Because I'm getting this is that. This is the X, but what do you?
I just told you.
How do you get 16?
-4 squared is what?
Oh, 16. Oh, okay, girl. Okay, but the attitude was looking for X. It really wasn't.
I apologize if it came off as attitude. It wasn't my intention.
So this right here, to just do this, so we have to do all 3 of these?
Yes.
Okay, and just to do this one, you have to plug in this and this,
Yes.
and you put it here.
Yes. I would do it in my head, but as a teacher, I have to write it out
Yes. So this is.
because I have to show you. You have to see what's in my head.
Okay, and what is this?
The point.
Which is where we start.
Okay.
So we plugged in our X. And out of X, you get your Y, our input, our output. So now I'm inputting -2, which is 0.5 times -2 squared. I'm going to use PEMDAS and evaluate, right? What is -2 squared? 4. What is half of 4? 2. So at -2, I'm going to go to 2. Okay? Are you with me?
Yeah.
Did I lose anybody along plugging in values?
No.
Okay? And now I'm going to connect them.
Wait, you are, oh, 8 is my body.
So now I'm going to connect them. It's going to be curved because it's a quadratic, and quadratic has a little bit of a curve because it says x squared. Remember, quadratic is x squared. It's one of the 3 functions that we've been using all year so far. Okay. All right. Now we're going to do it again for the next one, for the second one. So now on the second one, where do we start? We already have the dash line, and where do we end? So my other boundary line is going to be at 2. Okay, so now we're going to do f of -2 for this function. And that's just going to be -2. But at this one, is it open or closed? It's open. Why is it open?
-2 go first, go back to the end.
It's strictly less than, right?
Oh.
It's not defined there. Good job. So we're going to go to -2, and it's going to be an open circle at -2. Okay, now we're going to do f of 2, which is pretty easy for this one. It's just going to be 2. So I go to f of 2, and I'm going to go to 2. And again, it's a what? Open circle. Why is it open? It's not equal to. Okay, and from here, this is what type of equation? Linear. So it's going to be a straight line with a slope of 1 from here to here. Pretend that that's a very straight line. I know it looks like. Okay, are we okay? All right, now we just have the third piece to do. This time our boundaries are from 2 to 4. We already have 2 drawn out, so we're going to draw in 4. Okay, now we're going to find f of 2 for this one. So we're substituting in 2 in. That gives us 2 squared minus 4. What is that? 0. 4 minus 4 equals 0. So at 2, we're going to put 0. And is it open or closed? Closed. So I'm going to go to 2, go to 0, and I'm going to put a closed circle. Good? All right, now we're going to do f of 4. F of 4 is going to go off the page for me. So we have 4 squared minus 4, which is 16 minus 4, which is what? 12. So at my 4, remember I said it's going to go off the page for me? Okay. And now I'm going to draw a curved line to the best of my ability. And why is it a curvish line? Because it's square, because it's a quadratic. If the x is the exponent, it's a what? Exponential. So we've had linear, quadratic, exponential. Linear, quadratic, exponential. That's all we've been working with, right? All right, we drew it. We did it. Yay! Okay, so it says, determine if the graph is continuous. So the way you determine if the graph is continuous is if, as we go through the graph, is every x value defined? Okay? So does -4 have a value?
Yes.
Yes. Does -3? Yes. Does -2? Yes. This is its value, not this open circle. Does that make sense? And we keep going. -1 has a value, 0 has a value, 1 has a value, 2 has a value, 3 has a value, 4 has a value. So is this continuous?
Yes.
Yes, it is continuous.
Okay. And I was talking about-
Then I would have double open circles at a point. Okay? Do I have any double open circles at a x value? The closed circle means it's defined, that it's equal to. It's a value. Okay? But this is the entire function. So this is an entire function pieced together. Okay? All right, so our domain. Is from no, you don't have to. -4 to 4, and it is what? Continuous. All right, we will pick up here on, what time is it? Monday.